International Microwave Symposium 2023. We're in San Diego. I'm Martin Rowe with EE World. I'm here with Greg McCaskill of Rohde Schwarz. And Greg is going to explain to us, sometimes you have problems when you have RF and baseband and you don't know, is my problem in the RF or is my problem with the baseband? And Greg's going to explain how to use an oscilloscope to hone in on the problem. So Greg, why don't you take it from there?
Thank you, Martin. Thanks for having me. So we're using an oscilloscope here to capture the both the RF and measure the EVM and measure the EVM in baseband. And a scope is well suited for very wide analog baseband measurements because it has inherently wide bandwidth. So in this case, we're looking at a 600 megahertz wide analog baseband. We did find a problem with EVM and RF. We wanted to see if that was our up converter, our modulator, or present in baseband. We measured the baseband, and in fact, the EVM is also a problem, or it's higher than we want. And a scope can also let you do things like look at the time domain signals of the analog trace. And here I've zoomed in, and we see that there is a skew between I and Q. There's a skew or a phase misalignment. You can see that in this XY plot as well, that you've got an opening here. The scope will let you...
It's these two openings that we're seeing here. That's where the misalignment is occurring.
That's right.
Okay.
That's right. And if you remove that skew, this alignment will flatten back up. And you can have the scope measure a simulated correction to your device.
Okay.
You can simulate fixing that skew and remeasure EVM, and you can see that that does in fact improve your EVM. So if you make those design changes, you'll improve your EVM.
Okay, very good. Thank you, Greg.